Hello and welcome to another lesson on Introduction to Programming. Today we're going to be talking about decision making. So we as human beings, this is something we may take for granted. Maybe some of us don't do this as well as we should. But when we do programming, we have to tell our computer program, our computer, to make decisions. And how do we make decisions? But again, this is something that sometimes we do without even hardly thinking about it with our brains, where we make a decision where something comes up and okay, am I going to put on the right shoe first or the left shoe first? Or some of that's out of habit, but at some point we had to make that decision. Something as simple as that versus big life decisions. Well, in computer programming, we have to think through and break those things down to an even more elementary level as far as how do we make decisions based on what's happening within our program. So let's go ahead and dive in. I'm going to cover some concepts and then we'll jump to some code so we can see kind of how things work. So now in JavaScript, like in other languages, we can make decisions based off of yes, no, true, false, on, off type scenarios. So for example, if something is true, then let's do some sort of code. If it's not, we won't do that code. So it's like a yes, no type of scenario. So if 10 is equal to 10, then alert the 10s are equal. Now, well, in here with curly braces and semicolons, those are there for a reason. That's one of the biggest mistakes I see programmers make, and I still sometimes make them. IDEs help us, but we need to make sure we put our curly braces and parentheses and semicolons and stuff in the right place. Now, we can evaluate a whole bunch of different stuff. We can evaluate straight and literal numbers like you just saw. We can evaluate text, we can evaluate integers and things like that. But usually what happens is you're usually evaluating variables or functions that hold data. So in this case, my first variable is housing my number 10, my second variable is housing my number 10, and so this is equivalent to this if 10 equals 10, but we're just doing it with variables. So that's usually what happens. Usually you're not hard coding values into it. Now, if we want to, in the previous examples you saw, if this is equal to that, run one line of code. In most scenarios, we run more than one line of code typically. Usually our programs are more complex than that. So the way we do that is we just have to make sure we do like if-else's and things like that. So in this scenario, if something is equal to something else, do this, else do that. So if 10 is equal to 10, do this, else do something else. So we can, instead of saying, if this is equal to that, do this or else do nothing, we're saying if this is equal to that, do this, or do something completely different. So here is an example using variables. If my first variable is equal to my second variable, alert the variables equal, else alert that they are not. Okay, so we can, a lot of times you do this where you get the information. Now the number 10 is hard coded into these variables, but a lot of times you get this information either from a database or through AJAX, from a JSON AJAX XML file, pardon me, or from a user supplied information from a form or prompt or something. Yeah, it's usually not hard coded in, but you're usually doing this with user supplied information, whether directly or indirectly. So if you want more than one line of code, we just got to make sure we use those curly braces. Now, technically speaking, JavaScript doesn't require curly braces for one line of code with an if statement, but I tend to do it anyway just to get in the habit, because a lot of times I'll end up going back and adding in more lines of code and I don't have to worry about my curly braces. So here's more what you see. If something is equal to something else, then in the curly braces, and then else something else. Now notice here we can even nest if statements, so that's not an uncommon thing to do. I usually don't like to go more than 3. That's my personal preference, more than 3 levels deep. It can get confusing with nesting of if statements, so I want to make sure that we keep the complexity as low as possible. Pardon me. Now, sometimes we want to do what's called pseudocode, like writing our comments out. This is you'll hear me refer to term planning lists and things like that. They're called different names. Pseudocode is basically writing your code out, but doing it in normal English. If the current scene is equal to 0, run some code that does something. If the current scene is not equal to 0, do something, run some other code that does something else. So typically we can write something out, and that kind of helps us think through some of the logic, that planning list, and a lot of times we're not programming just by ourselves. Usually we're programming on teams, so talking it out and writing stuff out like this helps everyone be on the same page. Now, you also use a lot of operators in programming: addition, subtraction, multiplication, stuff that you probably learned in your basic math. But there's a couple here that you may not be familiar with. The modulus, how that works is whenever you have two numbers, you divide one by the other. What the modulus is what is remaining. So whatever the remainder is. A lot of times you use that to test whether something is even or odd, because if you divide by 2, for example, then anything you divide by 2 that's even will not have a leftover. Anything you divide by 2 that has a leftover will be odd, so you can test that way. And then you might not be familiar with the double plus and double minus. That's a way you can increment or decrement a value by 1. So sometimes we use that. When we get to loops, you'll see that as well. And then compound operators. These you see the equal sign that assigns value, but you can assign value and add. So for example, let's say I have a variable of x, like you see on your screen, and I want to add y to it, but keep the value of x. Let's say x is the value of 10, and I want to add x and y, so I want my value to be 25. Okay? If I want to keep adding to it, I could do like on the right hand side, x equals x plus y. I could do that, or I could do it in a shorter way, x plus equals y. And so what it does is called a compound operator. So those two statements are equivalent. It's not that x equals x plus y is wrong. It's just, as a developer, we're always looking for shortcuts and ways to do things faster. So compound operators help out a lot in that terminology. So if anytime you can use a compound operator, I recommend it. And then we have double equal sign tests equality. Now, triple equal sign also tests equality, but it tests more what we call absolute equality. What we mean by that is, let's say we have a number 5 and a string of 5. If we use the double equal sign, that will return true. If we use the triple equal sign, that will return false, because the double equal sign just tests value. Is the value of the number 5 equal to the value of the string of 5? Yes. So that would return true. With triple equal sign, it tests not only are the values equal, but are the types equal. Is a number equal to a string? In that case, no, so that will return false. Okay, and then there's the not operator with the exclamation point there. Anytime you see that, that usually reverses what it's comparing to. So like in my example there, x is not equal to 8, for example. And then greater than, less than, greater than, equal to, less than, equal to, stuff you've probably seen in math before. So then you have these operators. Double ampersand means and, double pipes means or, and I already talked about the not. So you can say, for example, in an if statement, you can say x has to be less than 10 and y has to be greater than 1. If both of those, if you're using ands, that if statement will only return true if both are true. If you use or, only one of them has to be true. X is equal to 5 or y is equal to 5. So only one of those has to be true in that. And you can do multiples. You could do x is less than 10 and y is greater than 0 and y is equal to 5. You know, you can do multiples. I've never usually gone more than 3 typically. It gets a little more convoluted after that, but you can do that. Now, I also want to address scope. Scope is context, basically. Where does the data live? Is it global or is it local? Global, I can access it from anywhere. Local, only accessed within a function or method. In some languages, they use different terminology. They use public and private, like in Java and C# and stuff. But this is kind of introducing you to an OOP concept called encapsulation, so protecting your code. So if you have a variable or information you don't want to have accessed outside that function, you make it local. So we want to encapsulate what varies. And so basically we want to encapsulate as much as we can. So when we're creating a program, there's times where we have to create some variables as local, or some variables as global. But we want to avoid that as much as possible and create as much local as we can, because the more global stuff we have, the more things can get messed up. Okay, but there's times where we have to do that. Now another programming process we can use is called a switch. Now if we look at the screen here, we have an if statement. So initially an if is designed to compare two items. So if some number is equal to 1, okay, then do something. But we can do else ifs here, like if some number is equal to 1, do something 1, else if some number is equal to, do something 2, and we can keep on going down the line. We can also do nesting and things like that, but sometimes that is inefficient. So if we're doing stuff like that, sometimes a better way to go about it is using a switch statement. A switch statement, we can test that same thing. See, we're testing some number variable here. We can do the same thing here, and we're doing case tests. So before we did, this is the same code, just one's an if and one's a switch. If some number is equal to 1, do something. If I go here on the right hand side of your screen, I'm testing the value of some number in my switch statement there in the parentheses, and in my curly braces I have all my cases I'm testing against. So case the value of 1. If that works, then do something 1. Case the value 2. If it's equal to 2, do something 2. So that's equivalent to if some number is equal to 1, do something 1, else if some number is equal to 2, do something 2. Now it's not that what you're seeing on your screen is wrong. It's just when you're programming, you're all about efficiency and doing things in an elegant way and having good quality, strong code. And sometimes if you have a bunch of if statements, it's just easier to do it in a switch. Okay. So notice the syntax, the switch statement followed by parentheses, and inside the parentheses is the variable data you're testing, and then the cases that you're testing against, and then some code in there. And notice the colons after the case values. Now there's one keyword you might see in here, the break. What that does is that kicks the logic out of the switch statement. So like let's say I'm testing, let's say some number is equal to 3. So case 1 is equal to no, it doesn't do that. So then it tests case 2. Is it equal to? No. Then it tests case 3. Is it equal to 3? Yes. So then it does the function do something 3. It found what it equals, so there's no need to do 4 and 5. So break kicks it out of that switch statement, so it makes it faster. So that's what that break keyword does. Now one thing I would recommend you do is have a default statement in there, so that if you go through like case 1, 2, 3, and 4 and none of those match, then you do have a default kind of a fallback of if all else fails, this is what I want you to do type of thing. So now let's go ahead and take a look at some code here. Okay, so here we have on our screen kind of a choose your own adventure. For those of you that are older like me, you may remember some of these choose your own adventure books. So we can say please choose 1 or 2, and I can click on a number. It says hey, your journey begins at a fork in a road, and then I switch to a new page. Take the path or take the bridge. I'll take the path. You arrived at a cute little house in the woods. Do I walk around the back or knock on the door? I'll walk around the back. Peeking through the window, you see a witch inside the house. Sneak by the window or wave at the witch. I'll sneak by the window. And there's nothing. To be continued. So let's see about how we did that, and then we're going to go through some iterations. Okay. If we look at our page, let me first look at the HTML. The HTML here, let me see if I can make this a touch bigger, so it may be a little easier to read for you. So the HTML is simply a div tag. There's an image. That's all those drawings there. Starts off at scene0.ping. And then we just have 2 buttons with an ID of decision1, decision2 that run a function called change scene1, change scene2. Now there's some logic here. So we have a global variable of current scene starting off at 0. Then we have this change scene function that we're calling from our button clicks here. Okay, so when we click that, excuse me, the first thing it does is creates a local variable called for the message, and test says, hey, if the current scene is equal to 0, which it starts off at 0 right up here. So if the current scene is equal to 0, we want to change the current scene to the number 1. And then make the message, your journey begins at the fork in the road. So the first time we click it, our current scene is 0, so this if statement returns true, so our current scene value is going to be made to be 1, and our message is going to say your journey begins at a fork in the road. None of these other else ifs or elses or whatever will return true. So when we come down here to the bottom, then what it does is it says, go into my document, get my element with the ID of scene image, which is my image down here, change the source to scene, and then in whatever the value of current scene is, which the first time it's going to be 1, scene1.ping. That's what changes that image from scene0.ping, scene1.ping. And then alert the message. Your journey begins at a fork in the road. So if I go back here, so there's my scene image, current scene 0. When I click that, your journey begins at a fork in the road, and it changed my image. Okay. Now, let's go to version 2, and let's see what we can do differently to make this a little better of an application. So, same image and everything. I click 1, your journey begins at a fork in the road. I click 1 again, you arrive at a cute little house in the woods. I don't see much of a difference here. Let me sneak by the window to be continued. But let's see what we did to try to make it more efficient on the back end. Okay. So on the back end, we've got our scene 1, scene 2. Okay. The first time I click it, current scene is equal to 0, changes it to 1. Now, what we did a little differently here is if we go back, let's look at what happens at the second click. Okay, where we're passing through this decision. Okay, we've got a nested if here. So on the second click, see, I'm passing through it. Here's the decision 1 and 2. That's how we know what button they clicked. That's the value of our decision variable. So if the current scene is equal to 1, then I'm testing, okay, if decision's equal to 1, that means they clicked button 1, change the scene to 2 and the message, or since it's not equal to 1, they know they clicked number 2, so change the scene to 3 and all that. So when we go here to the second one, we're doing the same logic here, okay? But what we're also testing down here is we have an if statement to test that whether our alert is our message is blank or not. See, here we're just alerting it, and I don't know if you saw it, but when I got to the end, it popped up and nothing was there. Excuse me, it was just an empty alert. But we want to make sure that it doesn't show up unless it has information. So we're testing if my message variable is not equal to 0, then alert it. Okay, so we're just testing to make sure we have something in this information. So now, so that's a minor change. Let's go to version 3 here. See if we make any changes here. We click 1. Your journey begins at fork in the road. Click 1 again. You're at a cute little house in the woods. 1. Sneak by the window. We go back. Okay. Now let's see what we did on the back end. Okay. On the back end, the logic is pretty much the same with the if-else statements. Okay. And just a couple things to point out. We did add some information down to here with the else ifs and scene 8 and 9. See, we didn't have anything there. We just added some comments for those. And then we want to make sure that as we're going through with this function else ifs, else ifs, and nested, you'll want to test this logic out and things like that, and we've got the value. But let me jump actually right to 4, because here we changed it to a switch statement. Same logic, but now if you look at this code, here's all the ifs and else ifs, and some of that may be kind of convoluted and you may kind of get lost in it of what matches what and everything. So if you go to switch, it may be a little easier in this case. Same logic, it's just a little bit different way to do it. So Here I'm doing change scene 1 again. In my function change scene, I'm just testing. Okay, first is my current scene. This is the same statement, just in a switch statement. Is my current scene equal to 0? Case 0, yes. Change the current scene to 1, change your message, and break out of it. See, the difference, big difference between these two is this one is going to test all these. Boom, 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 right down the line. This one is only going to test this one, and if it works, it breaks out of it. Now, this is a small application. So from a performance standpoint, you're not going to really see a difference. But when you start getting into building enterprise level applications, performance becomes a big deal. And so we want to make sure that we are designing things, even starting from small, in such a way that they are as efficient as possible. So if I have a huge if statement, I need to find a way to write that in an efficient manner, in this case changing it to a switch statement so that we can break out of it if necessary. But if you notice, it'll work the same way as before. Let me change it to, oops, wrong one, to number 4. There we go. There we go. So I hope this has been a good intro to if statements and switch statements and if else's and nested ifs and all that stuff. Every program you're going to build is going to have decision making capability. The hard part, I will tell you, is figuring out how to make that logic work. So, because I will tell you that in the real world, no one's going to come to you and say, hey, can you write me an if statement that's like this? And then rattle off the if statement. What they're going to do is they're going to say, I have this problem and I need you to solve it. And you got to kind of figure it out. And in fact, a lot of times they can't even articulate what the problem is. So it's sitting down and doing some planning lists and running through some logic, maybe on paper, some pseudocode to figure out, okay, if they click a button, I need to pass that information so we know what button they clicked. That's the decision here. And then I need to keep track of where we're at in the project. So here's a global variable to kind of keep track of where we're at as we change. So then inside here I need to change those up and then test that information so I can kind of keep track of where we're at and change information in my application. So play with this, and I hope that's helpful for you. If you have any questions on decision making, if statements, switch statements, nested ifs, if else's, whatever, let me know, and happy coding.